Hey students! Today I want to talk about acid nomenclature. So in acid nomenclature, the first thing we need to know is how to identify an acid. Right now we're going to use the Arrhenius definition of acids. We're going to learn more definitions of acids later on, but we'll just use Mr. Arrhenius' definition now. That's that in solution, acids produce hydrogen ions. Bases produce hydroxide ions. Now bases get named the same way as all ionic compounds, so we don't need to do anything special for bases, but for acids we do have special rules. So what does producing hydrogen ions have to do with anything? That means that acids begin with hydrogen. Could be 2 hydrogens, 3 hydrogens, 4 hydrogens. Not 4, I've never seen 4. 1, 2, 3, I've never seen 4 hydrogens at the beginning of an acid, but it might be there. Alright, so we break up acids into two categories, binary acids and oxyacids. So let's look at binary acids first. The rule for binary acids is to add the prefix hydro and add the prefix ic to the nonmetal. Now, I need you to remember this. Hydro simply means no oxygen. Hydro does not mean hydrogen. Is that confusing? Yes. Is that the way it's done? Yes. Sorry. So when I see HCl, I say, okay, Cl is chlorine. I'm going to add the prefix hydro, and then I'm going to change chlorine to chloric. So that's hydrochloric acid. When I look at this one, I see S for sulfur. So my base is going to be sulfur. I add my prefix hydro, and I add my suffix ic, and produce hydrosulfuric acid. Why don't you pause and try HF on your own? Hydrofluoric acid. What if it's the reverse process? What if you're given the word like hydrobromic acid? If you're given that and asked for the formula, it's not really hard. Just take the hydro and get rid of it. Take the ic and change it to IDE, and that spells bromide, which is Br minus 1. Now H is H plus 1, so use your charges and figure out what you get. What do you get? Well, you just get HBr. HBr. Or if it said hydrophosphoric acid, get rid of the hydro. It doesn't really mean anything right now. Let the ic become ide. That spells phosphoride, which is phosphide. Phosphide is P minus 3. H is plus 1. How many H's do we need? We need 3 H's, so the answer is H3P. Cool, huh? That's all there is to it. It's easy. Now, what about oxyacids? Oxyacids, obviously, are going to contain oxygen in them. And these are pretty much or always going to be related to polyatomic ions. The ones up top really we don't deal with polyatomic ions much. So, we're going to break our oxyacids up into two more categories. I called them, let's change color to orange in honor of the Clemson victory Saturday night. Ic acids and us acids. So we're going to break acids up into ic acids and us acids. So an ic acid, and these two examples here I'm just going to take out, change my mind. An ic acid would look like this. It's one of the ones that ends in ic, like nitric acid. An us acid would be one that ends in ous, like nitrous acid. Alrighty? So how do we take nitric acid and figure out the formula from that? Well, first thing we do is we know that ic acids come from 8 polyatomics. Not the number, but the suffix 8. And us acids come from 8 polyatomics. So look here, if ic acids come from 8, we can just cross that ic and change it to 8. That spells nitrate, which is NO3 minus 1. H is going to be plus 1. What's our formula? HNO3. So if you see acetic acid, vinegar, vinegar is a dilute solution of acetic acid. Ic becomes 8. That spells acetate, which is C2H3O2 minus 1. How many H's in front? 1, because it's plus 1 and minus 1. So the answer is HC2H3O2. That's how you deal with ic acids. Now, what if we're working in reverse? What if we're working in reverse? What if I have H2CO3? Well, then you just need to look up on your polyatomic list what CO3 is. CO3 is carbonate. We're going to take, I'm going to go ahead and write it. We're going to take 8 and drop it, by 8, and put in ic. That's carbonic acid. Please remember to write the word acid. These are acids. In fact, what does the word acid mean? Acid means the H up front. Not hydro or anything else. Acid means the H up front. Ooh, what about this one? HClO4. Well, all you have to do is look up what ClO4 is. ClO4 is perchlorate. Perchlorate. So what are we going to put in place of 8? Ic, perchloric acid. So in our oxyacids with polyatomics, the 8 ending changes to ic, and that's all there is to it. Now let's go over here to our us acids, like nitrous acid. Well, in our us acids, us goes with ite, so we're just going to take out the us, put in ITE. That spells nitrite, which is NO2 minus 1. H is plus 1, so our formula is HNO2. What if it says, and this one tricks lots of students every year, and I don't want it to be tricky. I'm telling you right now, lots of students mess this up. Hypochlorous. Us changes to ite, so we're going to cross out the us and change it to ite. Every year, students seem to think that I added this. This has some special meaning. That is just part of the polyatomic ion. I didn't add that. So what is hypochlorite? It is ClO minus 1. ClO minus 1. So how many H's are going to be in front of that one? 1. HClO is hypochlorous acid. How about sulfurous acid? Well, same deal. Us goes back to ite. That spells sulfurite, which is sulfide, SO3. SO3 has a minus 2, so how many H's? 2 H's in front. And that is the formula for sulfurous acid. What about working in the opposite direction? When you see this, you say, oh, what polyatomic is ClO2? ClO2 is chlorite. So we've learned that ite changes over to OUS. That is chlorous acid. Chlorous acid. Alrighty, so those are our acid rules. So remember, we have 3 types of acids. If you want to divide them up, we have binary acids. We have ic oxyacids and us oxyacids. And that is the end. Thank you for listening.